Welcome back to metric conversion and dosages, and to the last video on operations with fractions and decimals. Time to concentrate on fractions. Let's start with 3/5. Let's say you want to express that as a decimal. Okay, so where is the fifths place? It's fifths, so it has to be the right of the decimal, but where is that? Oh wait, we don't have one. We do have tenths, we have hundredths, we have thousands. If we could express 3/5 as something over 10, we'd have tenths, or something over 100, we'd have hundredths. Let's just go with 10 for now. What will we have to do to make that 5 a 10? So let me multiply that by 1. 2 over 2 is equal to 1. When I multiply fractions, I multiply straight across. No cross multiplication here. We're not going across an equal sign, just straight across, top and bottom. 2 times 3 is 6, and 2 times 5 is 10, so 6/10. Oh, I can write 6/10 as a decimal. Handy trick there, changing a fraction into a decimal without doing division. Example B, 17/20. What might that be as a decimal? Well, I have tenths, I have hundredths. Oh, if I multiply 20 by 5, I would get 100. But if I multiply that in the denominator, I have to multiply by the same thing in the numerator because I want to multiply by 1. So 20 times 5 is 100. Let's see, 17 times 5 is, 7 times 5 is 35, carry 3, 85 hundredths. So 17 over 20 is equal to 85 hundredths. Now this is a technique known as finding equivalent fractions, because 3/5 is equivalent to 6/10. They are the same number expressed differently, just like this is the number 1 expressed differently. Okay? What if we went the other way? Oh, and let me write this one too. 17/20 is an equivalent fraction to 85 100ths. That's a pair of equivalent fractions there. What if we were working in the opposite direction? What if we were given 0.85 and were asked to express that as a fraction in its simplest form? Well, 85 hundredths is equal to 85 hundredths, 85 over 100. That probably will reduce, won't it? So what you need to do now is start looking for factors that are common to 85 and to 100. What factors of 85 are also factors of 100? And try to find the largest one. That'll make this easier. So if I divide 5 out of the top, wait a minute, I can't just touch the top. I have to divide by the same thing in the denominator, because then I'm multiplying by what? Dividing by what? I'm dividing by 1. Dividing by 1 does not change the number, although it may change what it looks like. 85 divided by 5 goes in there. 5 goes into 8 one time. That leaves 3 left over. 5 goes into 35 7 times. 100 divided by 5 is 20. So, once again, 85 hundredths is equal to 17/20 by dividing by 1. In the form of 5 over 5, I proved, once again, that 85 hundredths and 17/20 are equivalent, which also means 85 hundredths written that way is equivalent. Okay? You can move back and forth easily between decimals and fractions as you become comfortable with it. And remember from the previous video that the decimal, or the fraction, 85 hundredths is also equal to, let me put it in black like the rest of it, 85%. 85% equals 0.85 equals 17/20. From the first video, now it will be example D, but that's 4.1. Okay, this is going to look a little bit different because we now have a whole number and a decimal number. And we know the whole number is not a fraction. The whole number is, well, it's a whole number. And we have 1/10. So 4 and 1/10 is equal to 4 and 1/10. They are read the same way, they're just written differently. They mean the same thing, just a different format. Okay, is 1/10 as simple as it gets? Yes, it is. But sometimes you don't want a mixed number. Sometimes you want a pure fraction, even if it is an improper fraction. So we need to combine that whole number with that proper fraction. By the way, a proper fraction is proper because it's not going to tip. The bigger part is at the bottom, and the smaller part is at the top. So it is proper. Something like 100/30 that has the larger number on top is kind of tippy, is liable to fall over. Okay, that is an improper fraction. So we're going from a mixed number, it's going to give us an improper fraction. It's going to have the larger part on the top. So I am going to give you a little bit more explanation here. Okay, if you have 4 of something and you break them each into 10 parts, then you have 10 parts out of the 10 parts for that whole one there, and 10 out of 10 for this one, and 10 out of 10 for this one, and 10 out of 10 for this one. So you have 10 tenths here, 10 tenths here, 10 tenths here, 10 tenths here. So how many tenths do you have? 10, 20, 30, 40. You have 40 tenths. And you also have 1/10. Okay, so there's the 4 becomes 40 tenths, and you have that 1/10 still. So 41 tenths is equal to 4.1. But yeah, I usually don't go to the trouble of doing all of that. Instead, I look at 4 and 1/10, and I say, 4 times 10 is equal to 40, and then I add the 1. So instead of 40, I have, should have used a bigger eraser, 41. And my denominator is still tenths. So 4 times 10 plus 1 gives me 41, and I keep the same denominator. Let's look at 1 2/5 times 3/8. All right, with fractions you multiply straight across, but wait a minute, I don't have 2 fractions. I have a mixed number and a fraction. I need 2 fractions in order to multiply. 1 2/5 equals, well, I say 1 times 5 equals 5, plus 2 equals 7. So I have 7/5. Therefore, 1 2/5 becomes 7/5, and I'm multiplying by 3/8. Now I have a fraction times a fraction, so I will be multiplying straight across. 7 times 3 equals 21. 5 times 8 equals 40. Now, if 21 and 40 have any common factors, I must reduce. Let's see, 21 has 1, 3, 7, and 21, none of which other than 1 are factors of 40, so I'm done. All right, here's example F. I have 1/2 times 3 and 3/5. I have 1 fraction times a, mixed number. Okay, so 3 and 3/5 equals 18/5. So 1/2 times 18/5. Once again, I'm going to multiply straight across. Okay, and 1 times 18 is 18, and 2 times 5 is 10. Oh wait, that's not in lowest terms, because 18 and 10 both have a factor of 2. So I'm going to divide by 1 in the form of 2/2. I'm going to get 9/5. There we go. Lowest terms, but it is an improper fraction. And maybe you want it as a mixed number. What do I do now? Okay, we're going to kind of reverse the process. We are going to take 9 and divide it by 5. How many times does 5 go into 9? It goes 1 time. I do a subtraction, and I have 4 left over. That is 4/5. 1 4/5 is equivalent to 9/5. Now the reason I can do that is that 9/5 is equal to 5/5 plus 4/5. So this 5/5 is equal to that one. So again, we have 1 4/5. All right, let's do a little bit of division with fractions now. example G. And okay, it's not in red because it's going to be terribly difficult. It's actually, once you pretty straightforward. You just have to remember one thing. 3/8 divided by 1/2. Well, when you are dividing by a fraction, here's the fraction you're dividing by, you're going to multiply by the reciprocal, or some of you may know it as keep the first number the same, change this to a multiplication problem, and flip the last fraction. Okay, so you're multiplying by the reciprocal. The reciprocal just being what you get when you take any fraction and you flip it upside down. That gives you the reciprocal. Okay, it multiplies straight across as we did before. 3 times 2 is 6, and 8 times 1 is 8. Oh, that is not in lowest terms. Let's divide a 2 over 2 out of that. So we get 3/4. Now I want to show you something because we're going to move on and get a little fancy here in a bit. Many of you will take a look at that 6/8 and do something called canceling. When you are canceling, you're doing this, okay? You're just doing it more in your head and quicker, which is fine. But what you're going to be saying probably is that, oh, let's see, 2 goes into 6 3 times, 2 goes into 8 4 times. That gives me a 3 in the numerator and a 4 in the denominator. Same answer, either method. In fact, you could have canceled quite a bit earlier. What you could have done instead is to say, oh, here 2 goes in there once, and 2 goes in here 4 times. So multiplying straight across, I get 3/4 again. Woohoo! Finally, the last topic, the addition and subtraction of fractions. So here we go with addition. Okay, when you add fractions, it's really easy if they have the same denominators in each of the fractions that you are adding. When we are adding fractions, we add straight across, but only in the numerator. The denominator stays the same. Whatever denominator is common to all the fractions you're adding, that is the denominator in your answer. 3 plus 6 is 9, but that's an improper fraction. It is reduced as far as it will go, but if you need to turn it into a mixed number, 8 goes into 9 one time. How many are left over? 1, and that 1 goes over the denominator 8. So 9/8 is equal to 1 and 1/8. So something like 2/5 plus 1/2. You need to find the least common denominator, or the lowest common multiple of 5 and 2. So let's see, the multiples of 5 are 5, 10, 15. The multiples of 2 are 2, 4, 6, 8, 10, 12, etc. But look here, we have already found a common multiple. That is the least common multiple. There will be others. But now we have to convert 2/5 and 1/2 into equivalent fractions that have 10 in their denominators so that we'll be able to add them. All right, what do we multiply by 5 by to get 10? We multiply by 2. So we're going to multiply the denominator and the numerator by 2. Okay, we're going to multiply 1/2 by 5/5, and so we can rewrite 2/5 as 4/10, and we can rewrite 1/2 as 5/10, and when we add those together, 4 plus 5 is 9, and we keep the common denominator. That cannot be reduced any further. We are done with that problem. With example J, we will be moving into subtraction. Notice that the denominators are not the same. So the first thing we need to do is find a least common denominator. All right, to do that, let's look at the multiples of 12. 1 times 12 is 12. We'd have 24. We'd have 36. We'd have, wait a minute. Let's try 8. 8 times 1 is 8. Times 2 is 16. Times 3 is 24. Ah, there we go. We've found a common multiple. We can stop there. Now we know our least common denominator must be 24. So we're going to take 7/12 and figure out what we need to do to get a 24 in the denominator. That is multiply by 2. So we will do that in the numerator as well. So 7/12 becomes 14 over 24, 14/24. And 3/8. What do we have to do to 8 to make it come out as 24? We have to multiply by 3 and multiply 3 by 3 to get 9. So now we have 3/8. Well, we don't have 3/8. We have the same value, but it is expressed now as 9/24. And 14 minus 9 is 5. And keep the same denominator because we're doing subtraction. There's our final answer. Okay, time to move kind of sideways. We're now going to apply this same principle of finding a least common denominator when we're adding or subtracting to the case of mixed numbers. Let's look at 5 1/3 plus 2 1/3. Okay, we have mixed numbers there. The nice thing about mixed numbers is you've got some whole numbers there. You can add the whole numbers. 5 plus 2 is 7. 1/3 plus 1/3, you can now add the fractions to get 2/3. If you want your answer as a mixed number, you're good. Moving on to example L. 8 3/4 plus 1 1/2. If you don't start with common denominators, you better be finding them though, because we could go ahead and add 8 plus 1 to give us 9, but we cannot yet add the 3/4 and the 1/2. So we're going to have to do a little bit of work. 3/4, 1/2, what is a common denominator? Just looking at those, you can tell 4 is the least common denominator. In fact, for 3/4, you don't have to do anything. You don't have to change it at all. For 1/2, you're going to have to multiply the denominator and the numerator by 2. So our original problem, and usually what I do is I'll write a little arrow like that out to the side and say 8 3/4 plus 1 2/4. Okay, keeping the whole numbers written as they were, but putting in equivalent fractions where needed. Okay, now if we add these, we get 9, and 3 plus 2 is 5. Common denominator is 4. Oh, wait a minute. We have here a whole number and an improper fraction. Okay, sometimes it's okay to have an improper fraction, but not as part of a mixed number. We need to change that. So working in a scrap area of my paper, 5/4 is going to become whatever I get when I take 4 and divide it into 5. Well, 4 goes into 5 one time. And what do I have left over? I have 1 left over. Okay, so 5/4 equals 1 1/4. So what we have here, this 9 5/4 now becomes 9. It is already 9 plus 5/4. So this is the same thing as 9 plus 1 1/4. Which is easier to do if you write it as 9 plus 1 1/4 vertically. 9 plus 1 is 10, and nothing plus 1/4 is 10 1/4. So our final answer here is 10 1/4. All right, but what about subtraction? Okay, subtraction with mixed numbers is also easy if you have a common denominator in the fractions. So we're just going to do the whole numbers first. 5 minus 2 is 3, and 3/4 minus 1/4, they have the same denominator. Therefore, if it helps, sometimes with fractions themselves, it's easier to do it horizontally. So the denominator remains the same, and 3 minus 1 is 2. However, that is not lowest terms. 2 goes into 2 once. 2 goes into 4 twice. So 1/2 is what you get when you subtract 1/4 from 3/4. 3 1/2 is the final answer for that one. Next will be example N. We will need to combine techniques for this example. Okay, we could do 7 minus 3. That would work out fine. That would be 4. But when we look at 1/4 minus 5/6, what's that going to be? It looks like we're going to have to find a common denominator and some equivalent fractions to do this subtraction. So this time let's move our original problem over a little bit, and we're going to rewrite it as 7 and 3/12 minus, I'm just going to leave the minus sign out here as I did with the plus sign earlier, 3 and 10/12. Okay, looks good. Except, can we do 3/12 minus 10/12? No. I need more value in this fraction. Where am I going to get that? Well, I'm going to get it from the 7. Because 7 and 3/12, if I pull a whole number 1 out of the 7, I would be left with 6. And that 1 would give me 12/12, and I'd already have 3/12, so I would have 15/12, in addition to the 6 that I already had. So 6 and 15/12. 7 and 3/12 becomes 6 and 15/12. 3 and 10/12 does not need to change. We need to remember that we are doing subtraction here. So 6 minus 3 is 3, 15 minus 10 is 5, and the common denominator is 12. Is this in its simplest form? Can it be reduced anymore? Yes, it's in its simplest form. No, it cannot be reduced. So yes, this is the final answer. 7 1/4 minus 3 5/6 is 3 5/12, and yay, I am done. That's all of the operations with decimals and fractions that I intend to cover. If you have any questions, any and all, about anything that I have covered in parts A, B, and C of this video series, feel free to contact me. I'd love to discuss it with you, and thank you for sticking with me through all these videos.